Welcome to this maths challenge video. And this week's challenge is called Paving Problem. And in order to do this, I've got some dominoes here and I'm using these. And the great thing about dominoes is that they are twice as wide as they are tall. Okay, so I'm going to use this fact. So for this problem, I'm going to say that this is 2 units and this is 1 unit. Now, I'm going to do this to simulate making paths. So if I wanted to make a path that was 1 unit long and 2 units wide, there's only one way I could do that. I could have one slab just like that. Okay, and then it is going long, it's 1 unit, and it is 2 units wide. Okay, there's only one way I can do that. Now, if I wanted a path that was 2 units long, again 2 units wide. Now, all my paths I like to have 2 units wide. Okay, so if I wanted to make it 2 wide, then I could have one there and one there. That's one way, isn't it? Okay, if I move it there, you can see the gap a little bit clearer. But I could also have one there and one there. So there are 2 ways I can create a path that is 2 units long and 2 wide. Again, 2 wide there. So there are 2 ways. So if we have the length here and the number of ways here in a little table, when it's 1 long, there was 1 way. If it's 2 long, there were 2 ways. I think I can spot a pattern here. Make a prediction. I reckon this is going to be 3. So if I make a path that is 3 long, and I'm going to write these down as we go. So one way I could do it is to have 1 way, 1 slab, 1 slab, 1 slab, just like that. So that's 1 way, isn't it? Now I'm going to write that. If I move these over here, that is down, down, and down. That is 3 units long. But I could also twist these 2 round. And I've got another way, haven't I? So again, it's 3 units long, 2 plus 1 long, and 2 wide. So this time it goes 2 across and 1 down like that. But I could put this one at this end here. And again, I've got 3 long, 2 wide, but a different way again. So I have 1 there and 2 across there. So there are now 3 ways. My pattern here is looking pretty confident now about this. So for 4 long, I've got an extra 1 here. I reckon there should be 4 ways of creating these. I'm going to draw these down here. So again, if we start 1, 2, 3, 4 long, so we have 1, 2, 3, 4. That's 1 way. Now I can twist these 2 round here. That's another one. If we look, it's 4 long, 2 wide again. So we've got 2 across and then 2 down like that. Now these 2 like this could go in the middle, couldn't they? So that's another way. Okay, so we have 1 down, 2 across, 1 down, and then finally that one there could go there. Again, it's 4 long, 2 wide again still. So we've got 2 down, 1 across, which is 4 ways. It looks like this pattern holds. But there's a little problem here. I could also twist those 2 round like that and get another way of getting 4 long and 2 wide. So in fact I could put them like that. So there are in fact 1, 2, 3, 4, 5 ways of doing this. Now, what I'd like you to do is to investigate the length of the path and the number of ways you can create that path. Now, as you saw, this is very easy to do. If you've got a set of dominoes, then it's really easy to go and do it with dominoes, and you can actually physically make the paths. If you can't do that, then it's quite easy. If you've got a bit of squared paper or just draw lines, then you can do it like this. But I'd like you to investigate, is there something in this pattern? So it goes 1, 2, 3, 5. So what happened to 4? What would be the next one? How many would there be for 5? How many would there be there for 6? And if you can spot this pattern, is there a name to this pattern that seems to exist? Okay, I'll give you some solutions and extend this problem next week.